Hi everybody, today we're going to talk about combinations of functions. In this video we're going to go over 4 different combinations of functions. We're going to add, subtract, multiply, and divide. And luckily combinations of functions are things you would do even if I didn't tell you what you're supposed to do. So like if it says f plus g of x, it means you're going to add f of x plus g of x. Same thing, if I say f minus g of x, you'll subtract f of x minus g of x. F times g of x will be f of x times g of x, and then f over g of x is f of x over g of x. It's really important that the domain has to be the set of x that are common to both the domain of f of x and g of x. So if x doesn't belong to one of them, we couldn't use it all together. We also need to say with the division, you can't divide by 0. So when we do f over g, we just don't want to use anywhere where g of x is equal to 0. So let's take a look at that. We'll start pretty small. I have f of x is x plus 5, g of x is 6x minus 3. So to get f plus g of 10, I'm going to do f of 10 plus g of 10. So f says take the 10, add 5. G says do 6 times 10 and then minus 3. 10 plus 5, there's 15. 6 times 10 is 60, and then I have minus 3. So I have 15 plus 57. So this way I'm showing you what is g of 10, what is f of 10, and then what happens when I put them together. So 15 and 57 gives me a grand total of 72. If you wanted to, you could do this differently. You could start by saying, what is f plus g of x? So that says we would take x plus 5, and we would add 6x minus 3. So x plus 6x, that gives me 7x. And then 5 minus 3 gives me a positive 2. Then I could do f plus g of 10 is 7 times 10 plus 2. We know 7 times 10 is 70, plus 2 is 72. We got exactly the same thing either way we did the math. So let's try again. This time we're going to do r of x is 18x and c of x is 15x plus 300. So I'm going to start with r minus c of 10. So I'm going to do 18 times 10 minus, let's do parentheses, 15 times 10 plus 300. Really important that you put that parenthesis around the subtraction so that you're subtracting both of the numbers. 18 times 10 is 180. If I do 15 times 10, that's 150 plus 300. So I have 180 minus 450, which is negative 270. So the R and the C, I put in on purpose to stand for revenue and cost. So revenue is how much money a company brings in. Cost is how much money they have to spend to make those items. And you can see here that if this company only sells 10 items, that they're going to lose $135. So let's do a little bit bigger number. I have R minus C of 200. This is going to be 18 times 200 minus 15 times 200 plus 300. 18 times 200 is 3,600. And this time I'm just going to do the whole thing at once. So I'm going to do 15 times 200 plus 300, which gives me 3,300. So this time 3,600 minus 3,300 says we have $300, and that would be the profit. So revenue minus cost is profit. So I would like you to see some kind of application. Let's look at that application just a little bit more before we go back to more algebra. So I thought we could look at something like Apple. So you can see that this is Apple's revenue and net profit from 2013 up to 2022, and it's given in quarters. What I hope you really notice is that these blue bars are very high. So we have this very high revenue. This is given in millions of dollars. Then you see this much smaller in green, the net profit. So this difference between the revenue and the profit is the cost. So think about how much they have to do to develop new products, how much they have to pay their employees, and all the things that go into making the products that they have. Let's look at it a little closer in, and here's the revenue and the net profit just from 2011 to 2015 over a smaller number of years. It's a little bit easier to see it, but there is this big gap between the two quantities, revenue and profit. I thought it might also be interesting to look at that if I put it into an Excel spreadsheet. So I made up these numbers. They are not the Apple numbers, just something small we can look at. So you have a column of revenue, a column of profit, and I want to come up with a column of cost. What's nice is I can do this like this combination of functions. So I can say equals, and I want to do revenue, so I'm going to click on that cell, minus the profit, click on the other cell, and see where it says it's going to subtract the two. And then I will just drag that down to fill it in. What I wanted to show you is that makes sense as long as the revenue and the profit both have values. If I try to drag this down to the last line where I didn't put anything for revenue, it doesn't quite make sense that I got a negative cost. You can have a negative profit, but you can't have a negative cost. You're always going to spend money. This shows you that importance that the domain is the same between the functions that you're comparing. So if I went back over here and I made up a number, let's say we put in 68, then I have a real value that makes sense. To see this graphically, I'm just going to quickly do a little graph. I like this visualization that the top line is our revenue, the bottom line is our profit, and in between it shows us the cost. So we can see how the three go together. So it's a nice way to look at combinations of functions where we have it in a table and we have it in a graph. So as we move on, we want to talk about the domain a little bit more, and I want you to remember that the domain is the set of all the values of x for the function. There are typically two things you're looking for when you start talking about domain. You look for fractions and radicals. If there's any x in the denominator, we want to make sure that the denominator will never be equal to 0. If there's any kind of square root or even root at all in the function, then we want to make sure we take that piece of the function and we set it greater than or equal to 0. And of course, both things can happen at the same time, so you really do have to watch out for what's going on in each function. So let's look at this one. I have f of x is 3x plus 1 and g of x is 7x minus 2. We are going to do addition, subtraction, and state the domain for each one. So f plus g, I have 3x plus 1 plus 7x minus 2. I add the 3 and the 7, that's 10x. I add 1 minus 2, that's negative 1. Notice there's no fraction, there's no radicals, so my domain is all reals. I'm going to write negative infinity to infinity. So for f minus g, I'll have 3x plus 1 minus 7x minus 2. So this is 3x plus 1. I want to distribute the negative, so I have negative 7x, but now let's say plus 2. So 3x minus 7x is negative 4x, and then 1 plus 2 is 3. Again, since I don't have any fractions, I don't have any radicals, my domain is negative infinity to infinity. Let's keep those two functions and let's do the multiplication and the division. So I have 3x plus 1 times 7x minus 2. If you wanted to, you can multiply this out, 21x squared minus 6x plus 7x minus 2, which is 21x squared plus x minus 2. And then f over g would be 3x plus 1 over 7x minus 2. For the multiplication, the domain is still negative infinity to infinity. The domain for f over g is different. I want to make sure that 7x minus 2 is not equal to 0. 7x won't be equal to 2, and x will not be equal to 2 over 7. If I write that as an interval, I would say negative infinity to 2 over 7, union 2 over 7 to infinity. So let's change our functions. This time I have f of x as a square root of x plus 2, and I have g of x as x plus 4. So when I add them, I have the square root of x plus 2 plus x plus 4. I can't combine anything, so I have finished at this point. I do want to pay attention to x plus 2 being under the radical. I set it greater than or equal to 0. That says x is greater than or equal to negative 2. My domain is negative 2 to infinity. For subtraction, f minus g, I have the square root of x plus 2 minus parentheses x plus 4. I can drop the parentheses and make it the square root of x plus 2 minus x minus 4, but that's all I can do. The domain is the same as f plus g. It is negative 2 to infinity. For multiplication, I would have the square root of x plus 2 times x plus 4, and I would leave it like that. I would say the domain is still negative 2 to infinity, And then when I do division, I have the square root of x plus 2 over x plus 4. Now this time I do want to think about the x plus 4 in the denominator, and I think that x plus 4 cannot be 0, so x can't be negative 4. What happens though is negative 4 is less than this negative 2. If you think about what did we have already, we had negative 2 to infinity. This negative 4 over on the left doesn't change anything. It wasn't included anyway, so we don't have to worry about that this time. So I still have negative 2 to infinity as my domain. Let's take a look at that a little bit different. I am going to look at this as a graph. So I have f plus g of 1. So when I look at f plus g of 1, I look at f of 1, which this is the curve, and it's negative 1. And I look at g of 1, which is 1. So I'm putting these two things together. So negative 1 plus 1, that gives me 0. Let's try again f minus g of negative 1. So now over here at negative 1, I see f is negative 3, and I see g is positive 5. So I want to do negative 3 minus 5. So I have negative 3 minus 5, I get negative 8. The next one says f times g of 0. F of 0 is negative 2. G of 0 is positive 3. So I have negative 2 times 3 is negative 6. Our last one says f over g of 2. So f of 2 way up here at 6. G of 2 is down here at negative 1. So I have 6 over negative 1, which gives me negative 6. There's one more type of combination of function that we need to talk about. It's called composition, but I made a separate video for that, so make sure you take a look at it. It's a little bit bigger, so I wanted to spend a lot of time really diving into what it means. Good luck.